Okay, here's what's happening for this problem. This graph down here, this black curve is the graph of the function f of x, which is given as 6 times the square root of x. And we're asked to come up with an expression for the area under that curve on the interval from 1 to 12. Now this graph depicts 6 rectangles, but we actually want to come up with expressions for n rectangles and then let n approach infinity. Okay, but just so you can see what's going on, if the interval is from 1 to 12, that means the length of that interval is 12 minus 1, or 11. And if we divide that interval into n rectangles, then each will have a width of 11 over n. That's what this is right here. Each of these rectangles has a width of 11 over n. Except in this diagram, there's 6 rectangles, so it would be 11 over 6. Then each of these dashed black lines is a right-hand endpoint. So by the way, here's delta x, 11 over n. Each of these dashed lines is we're putting these x, so this is x of 1, this is x of 2, x of 3, x of 4, x of 5, x of 6. Of course, if we had n rectangles, we'd be going to x of n. Okay, and what we want to do is come up with some kind of expression or algebraic expression for each of these right-hand endpoints. Well, think of it this way. The x-coordinate of this first right-hand endpoint, we start at 1, and we add on one of these widths. So that's what this is right here. And to get to x of 2, we start at 1 and add on 2 of those widths, and 3 of those widths. And a formula for the ith right-hand endpoint is 1 plus I of these widths, 11 over n. And if we multiply 11 times I, 11i over n, and then get a common denominator, we could say that that's the expression right there. So the area of the ith rectangle is f of x of I times delta x. So we have to put each x of I into the function, which was 6 radical x. So there is x of I plugged into the function, so that's the height of each rectangle times the width. And that's a formula for the area of a particular rectangle, the ith rectangle. Now, what do we have to do to add up those areas? Well, we have to use summation notation. That's what this is right here. So if I go to board 2, where this summation notation means we're adding the areas of n rectangles from I equals 1 to n. There is the height of each rectangle. There's delta x, the width of each rectangle. So right here, that's a sub I. And we're adding n of those a sub i's together. And finally, we want to take the limit as n approaches infinity of the sums of those areas. So as n approaches infinity, the question is, what happens to all this? Well, I guess that's why the question did not ask you to evaluate that, because that's not so easy to do because of the square root symbol. But someday you'll learn that the area can be represented by this. Okay, and you'll learn to evaluate that and find the actual area. There you go. Hope that helped. If you have any questions, post a comment.